Whenever you want.
Perfect. Just like that.
Just like that.
Okay, so welcome everyone to the last two sessions, last two masterclasses from SPL with the one and only Mr. Herman. This is going to be an interesting one because we've been leading up to this, and this is it. This is literally the pinnacle of it all. And I'm very, very happy to have you guys here. And our host, Mr. Sai Shravanam, thank you so much. Thank you for being here. A quick introduction to our host, and then he will carry on the meeting from here. So he's a very, very, very talented, extremely experienced, award-winning arranger, sound designer, mix and mastering engineer. He runs a company called Resound India, and I think has been making records for about 15 years and is the man behind contributing Indian classical music for award-winning projects for movies like Life of Pi in 2012, and even the blockbuster hit The Man Who Knew Infinity back in 2015. That's fantastic. And he also has a lot of experience in international music research projects in IIT Madras, Harvard Medical School, so much more. And in fact, I think he was the first audio engineer. Yeah, he is the first audio engineer to be featured on the Sound and Sound magazine back last year, sometime in July. So there's just so much. There's an entire, I was just going through Sai Sir's Wikipedia page, and there's tons of information. There's like so many awards, so many things he's done. And I'm so happy to have you, sir, here to host this event. And he's a user of SPL as well. And that's even more amazing. So thank you so much for being with us and helping us conduct this event. Over to you, sir.
Thank you so much, Vivin, for such a generous introduction. First of all, good afternoon from India. I welcome Mr. Herman Gia and Xavier to this wonderful session that Pro Musicals is arranged for all of us here in India. I would like to also congratulate Pro Musicals for 30 years contributing to sound in India. My experience with SPL was very, very recent last year. I was in a field recording for a blockbuster movie that came out from South India, and we were recording Indian folk musicians. And they were all drummers that would go so loud that the whole village could hear the folk drummers playing. We were in the site and we were recording with various different preamps, some of the finest preamps, and for some reason, I could never get the right sound despite changing so many microphones. We changed the signal path. We just could not get the right tone of the lower frequencies, to be precise, and the higher frequencies. We could manage a bit of the mids, but never the low and never the highs. And it was ultimately, with the help of someone, we managed to get a crescendo from SPL. And that's when I switched on the device for the first time. It looked so simple, clean faceplate. And I was like, okay, let's try this out. And when I started tweaking the knobs in SPL, and that's when I realized, where is this beast of a preamp coming from? All of a sudden, all the problems that we've been having over hours started to sound clean, right from the low ends to, especially when you record very high, loud sounding folk drums in India. The worst thing that happens is the distortion that you get in the high, mid and high ranges. Sometimes you can even think it's coming from a microphone, but it's actually not coming from a microphone. Sometimes through the preamp, the distortion could also be via the preamp. And when I started to tune in the SPLs, and it had it was so clean. It did not have various knobs for us to figure out sound. It was just tweaking one knob, and everything was so clean. And we had almost 6 to 7 hours of recording in open field with wind. There was so much distraction in the open field. And that was when I actually fell for SPL. I was like, where on earth is the circuitry coming from? How could it be so clean? And it's so beautiful to use the interface. That was my first introduction to SPL. And then after that, I do use a couple of their plugins for my mixing and mastering. So My first impression with SPL floored me. So I must thank you, Mr. Herman Gear.
My
We were
pleasure.
floored, and that song was a master hit in India. And I must say, but for SPL, we wouldn't have been able to capture such wonderful sound. So thank you very much. I had to say the story to you because I never thought I would meet you and speak to you. Thank you very much for such wonderful gears that you bless us with.
Welcome. And that's truly flattering. Yeah, I mean, goes all down to what the 120 volt rail gives you, and we've been talking about this in other classes before, but it's good to hear that from you, so because it's hard to really explain what all these improved specifications mean to the audio at the end of the day, and that can only be experienced like you did. And then
Yes.
you see the difference, you hear the difference between a standard rail that comes to its limits, operating at its very top of the operating voltage, cannot do anything more than that. And even if, as you said, in open environments, the peak level can be so loud. And I
Yes.
was just sharing before we started the session my experiences that we had when we did Formula One back in 2006, where we did the first races here in Europe in full surround on open racetracks with Formula One cars. And you can imagine the noise level that you have there. And but that's a different story. All I want to say is that this the headroom that you gain when you lift the operational voltage by, let's say, we quadruple what the others do. So, and you need to do that otherwise, because it's a logarithmic thing with levels, and you need to put so much more voltage into the operation that to achieve an increase in dynamic range, which is obviously measured in dB as a logarithmic scale, there is lots of voltage required to only get a few, like a 10 or 12 dB more. But that is all the difference it makes. And everything can be captured as it is. And our mantra at SPL is to get the electronics, the feeling that electronics have been used, to get that out of the audio. Because it should, in our opinion, it should not be part of the audio, the sound of electronics. What we capture is an instrument. What we capture is a vocal. What we capture is ambient noises. And that should be reproduced as they are. There may be situations where you want to add something and where you want to EQ, where you want to put some kind of a sound device in there. Yes, but to us, that is like a spice. That is something that you add if there is a lack of something. But if there isn't, we think you should not put anything else in there. Leave the signal path as clean as possible. And yeah, we try to make the electronics become inaudible. Take them out of the equation. And so that's my 2 cents on your experience, but I would love to get your experience somehow, because I like to share that with my audience. That's a very, very valid one, I have to say.
And what you were talking about, the clean signal path, was something that, because typically when you add a preamp and then increase the gain, there's a certain amount of noise that most of us end up hearing when you take in loud sources. And with SPL, it was so clean, trust me, so clean that when I came back to my studio and I was just going ahead to those empty places where I was trying to figure out where the noise from the preamp was, and it was null. Despite we not having some of the best power supplies, we were running on generators. It was incredible.
Yeah,
I can't deny the fact.
That's another thing that that you find, that it's almost like a void of, and you go to your speakers, are they really on? And the same thing here with the mastering equipment. When we exchanged mastering consoles with in places that there was always a little background noise in there, which everybody was actually comfortable with because that's the way it is. And when we put our stuff in, they were like, "Oh, can you switch it on?" Well, it is on. Well, no, it isn't on. They were like puzzlement in terms of, yeah, it is on. No, don't make it any louder and then press play. Don't do that. It's going to be too too loud then. So I have to say that we've been really blessed with the fact that we were able to walk this road and design our own operational amplifiers. And I know that it is a hard road, and I spoke about that in one of the previous sessions, and it took us years to get there, but it was for us the only choice to really improve on analog audio, where everybody else was trying to improve digital audio. But digital audio, in essence, is cool to capture, to work with it, to cut, to edit, to do all these sort of things, and to work on a budget. It's perfect. I mean, we also do plugins, and people often ask us, "Hey, you got an iron plugin. How good is that compared to the real analog world?" Now, what are you going to say? Right? It is like, it is 90% there, it is 80% there, it is 100% there. What does that actually mean? And you cannot really take this product out of the consens that it's been in. If it's in a digital working environment, it is part of a huge mixing arrangement within Pro Tools, Nuendos, whatever, Cubase. It is part of that ecosystem, and all of that, how the algorithms integrate your algorithm into their algorithm, that's part of how it behaves and how it sounds. Obviously, in digital, the sheer fact that you have like a 0 dB margin or mark, you cannot go over that. It will sound horrible. That's always hard to manage in digital. In analog, especially when you have enough headroom, you don't even think about it. And that is a beauty that you learn when you start to use it again. Now, many people come from the back in the 80s where they use big consoles and stuff like that. And obviously when you run a console, the noise level on a single channel is already minus 80 dB. On 20 channels opened up, it's like minus 60, minus 55, whatever. You just hear in your speakers just because of all of the electronics in the path. And that's, again, when you add electronics in the path, then it becomes even more important to take a look at the rail you run and to use equipment that has a higher rail in order to bring the noise floor down if you are looking for that quality improvement. And that's why last time I spoke about the Neos console over there, where we built this to test this effect. And we had like 16 channels on 0 dB on this. And on the output, we had minus 100 dB on signal to noise, or minus 100, compared to, on a single track, it was minus 114 on a single stereo track, compared to minus 80 on a conventional console. And it's just a different world. And that's the void of the absence of noise. That's one thing that puzzles you, and you think it's going to be really, this is clean. Yeah, but it's clean as been used to describe a sound. I would not really like to use it here because people then may think when it's clean, it's sterile. And that's a quality that they don't necessarily look for. But cleanness is, to me, is more sheer transparency, because you can look down to the bottom of things without any noise floor that is hindering you to look down or to listen deep, to listen into the faint musical things, especially when you do open field recording. You have all these subtle noises somewhere that vanish into the noise floor. But if the noise floor is not there, it becomes so much more natural what you hear that you probably can say more to that effect. Yeah. So my 2
Yes.
cents on this one.
Yes, thank you very much. Now coming to the topic of mastering, the most I'm sure many people would have logged in just for the topic mastering, because in India, if you see in the recent times during the pandemic, there's been a lot of music production that have been coming out. I would say almost a few hundred songs every day released all over India. And when you end up seeing credits, you realize that there's a lot of these people who are music producers, young arrangers, keyboard players, sometimes even singers, who would work on their song, and then on the credits you'd see mixed and mastered by so and so. And every time I sit for mastering myself, it's such a huge universe. If it's my own mix that I end up mastering, I think I've done a great mix, and the next day when I sit to master it, I realize there's so much more that has to be fixed, cleaned, the dynamic range, the loudness, there's so much that comes in at the stage of mastering. So that's when you realize that that's going to be the faceplate of all the work that has gone right from the creator to the mixing engineer, and finally the mastering engineer is going to deliver it to the platforms. And now with all the loudness wars, people think mastering is loudness, while myself as a musician, I know what dynamic range is. I know how important it is to keep the dynamic range of a song, yet take it to the optimum loudness. And even in that, there's so much study. I just saw Mr. Shrijesh, and we have very nice engineers in India who have tried to educate many people on the aspects of loudness also. That's when you realize how important are these processors. And when I work on plugins and when I work on hardwares, there's a great deal of difference when I work on hardwares. Although I still don't own many hardwares, but I have worked in different studios across the world, and I realized that hardwares make a big deal. I just can't find it out in plugins, while there are people who would say, no, I can still get the same. But I could never feel it on emulations, because the way the signal you send through a hardware, the way the tubes react, the amount of hours that the equipment has been switched on, the amount of heat that's there in the tube, everything mattered to me. So I am here waiting for SPL to speak more about mastering, what their processors can do, your compressors, your EQs especially, because the smoothness that I get out of a hardware, I just could not get it out of a plugin. I must be very honest here. I don't know if it might be a statement of debate, but when I tweak in a hardware EQ, it's way different from doing anything in the box. But it doesn't mean in the box is something that you lose. You have way more convenience in the box with recalls and other things. So can I have your share of your research on mastering and all your products?
Sure. Yeah, we got to split this in two sessions, and yeah, for today, we're gonna take a look at PESEC and PQ and the iron compressor. So we do the processing side of things, maybe a bit of Gemini. Let's see how far we can go. And on Friday, we're gonna talk about the whole setup in the integration of processes into the monitoring and the recording chain. And so this is going to be mainly about the DMC as the centerpiece of the mastering studio, and then we add Hermes and how you can all get the most out of your gear by being free in how to route your signals through it. And it's a full switch box. It's a hell of a thing. And we're going to talk about what this gives you, as well as DA conversion and multi immersive audio monitoring. So that's for Friday. And for today, yeah, it's about these little babies over there. You can, I have this other screen here on my cell phone, and I think you can, if you use this one over here, I can show you a bit on
Yeah.
the process. Does it work for everybody?
Yeah, it's clean. Yes.
Okay, then it's good. Oh shit, my headset is not, cable is not long enough. I haven't checked that before, so I need to do something here. Okay, now up here is the PASEC, and I must say the PASEC is, this version is the older PASEC version. We have a newer model, but I still have this in my setup here. I will talk about the differences soon. Then we have the PQ mastering equalizer. This is the new version, and we have the iron mastering compressor here with the red faceplate and the black VU meters. You can also get it in black with yellow VU meters. But I like the look of this one. Now, when we started doing mastering processing, we started with the PQ. And this was the PQ 2050 that we developed in 1999. And it was the first processor that we made using the 120 volt rail. And at the time, we had a computer built down here behind all of the switches, because that unit featured motorized pots, and you had a storage field here. You can save up to 800 presets, and the motors will the motors would actually, yeah, give you a total reset, not just a recall. It was a total reset. A hell of a machine, I have to say. We still have one working, but over the years, so many parts were discontinued on the motor control side, on the computer side, that we couldn't produce it. And there was another thing that really annoyed us a bit. The fact that when you were making a recall and the pot was moving from here to there, there was a certain hysteresis on the motor. It wasn't so that the pot would stop here like this, and when it made a recall from that side, it moved in and it would stop there. So there was that slight difference. But this was only because of the clutch on the servo motor that did that. It wasn't on the audio, because the audio was the part that was actually compared. But engineers were saying, oh, it's not precise. Yeah, it is precise. It does exactly. No, but it doesn't look like to be precise. Yeah, and that was that. So now on this PQ, the idea was that we first of all, we wanted to have a full 5-band, fully parametric equalizer, and that was like you have five bands in series. The specialty is here that you can see this down here. Every band can be switched from a proportional Q to a constant Q mode. Now, I'm not sure whether that difference is known to everybody. I would briefly try to explain this to you. When you do constant Q, then let's say you apply a certain amount of amplification. Okay, let's say like 3 dB on some frequency that you selected, and you are using the broadest Q in constant Q mode. So you put it to 0.6 Q. So that's pretty wide. Now in that, your overall audio now becomes pretty loud, because that frequency that you select here is being boosted. And when you turn this, let's say you exactly get what have we here, 4 dB, and you turn it down to minimum Q, you will just hone in on that, and suddenly you only hear like a very narrow frequency band, and the overall level is coming down. So that means that you're using the Q in constant Q mode always requires a reset of the gain. That is not so cool when you try to work on finding a good sound. Constant Q was originally designed for graphic equalizers and to control PA systems. And there you need exactly this kind of a behavior. But what people forgot about then is the beauty of proportional Q. And when you put this to proportional Q, what happens is that the wider you select your Q, the lower the amplitude drops. So you can leave the amplitude, let's say at 4 dB. If you set this to a wide Q, it will effectively only be like 1 dB. Whereas when you turn the Q down, say you make it tighter, then the tight frequencies are suddenly having the full amplitude of 4 dB. Thereby, the sonic energy under the of the EQ'd curve is the same. So, and you only twiddle with your Q control, and you can ignore your amount of setting because it is pretty much adapted to the way we perceive it, to the hearing and the loudness of the hearing. So in order to do that, you literally build two different equalizers. So basically, this is not a 10-band equalizer. This is pretty much a 20-band equalizer, where you can switch each band into two different modes. Now, every channel has like its own on switch. And as you can see up here, there is a half gain switch, sorry, a quarter gain switch. In mastering, you will probably use it in a quarter gain setting all along, because then you get like plus and minus 5 dB. If you use it in the non setting for, let's say, recording application, or where if you have to tackle something really dramatically,
for 15,800
you can go up to plus or minus 20 dB here. So there is also possibility to link the switch settings. If you switch that button, flip over here, and you can see that I'm using the right side, and on the left side, all the switches follow. These are the master bypass switches, and there is a feature here in the center which we call the auto bypass. Now, what that does is it you select the timing with this interval control up here, and if you set it pretty fast, it switches between your EQ and the bypass. You don't see it, you only hear it. You only hear a slight click noise from the relays, but that's it. And thereby you can just focus on hearing without actually doing this. Because all the time, and I see myself when I worked on something for a long time, and I press it on, I want to have it sound better because I spend time on it. That's a psychological thing. So by using that auto bypass and selecting a time where it switches between on and off, you sort of don't get trapped in your own judgment, in your own prejudgment, I must say, by activating it manually. So the PQ was or is designed more for the corrective work. You tackle frequencies that you don't find matching or being loud enough or too loud in a mix. You try to emphasize certain things that help an instrument or a vocal to stand out. You can add super high frequencies up to 24K if you want to get this air band to emphasize that one. The bands are all very much overlapping. So when you take a look at the for example, at these two frequencies up here, I hone in a bit. You can see that this one goes from 10 Hertz to 330 Hertz, whereas this band already starts at 33 Hertz. So there is a huge overlap for these two bands coming from about here. This is the starting frequency of that following band. So this overlap allows you to also tackle things twice, or that if you have two issues that are very close by, yeah, you can do that because the overlap is that big. So for example, on the following band, this goes up to 1 kilohertz, and the other one, the next one, the mid frequency, starts at 128, right? So it even overlaps with the lowest band that goes up to 330 and has the 128 up here on the 2 o'clock position, right? Even the fourth band that starts at 310 still overlaps with the lowest band by 20 hertz. So that shows you that that you can really tackle things. Yeah, if you have adjacent frequency problems, you can really tackle them twice and in different bands. All of the pots are detention, so there are 41 detentions, and they are pretty precisely matching the dots that we have around it. So for recall purposes, that's all. I try to, I don't know if it's sharp enough, but you can pretty much see that this all works out pretty neatly. And you can create good recall sheets with just photographing this. Yeah, so let's stop here for a minute. Questions to this for now? Otherwise, I proceed with the passive equalizer.
No question on the
No.
written chat. on
All
my
right.
side.
Guys, you can just pop in. We like to have that. It's not last time we had like a very good conversation going on about things, and people were asking even off-topic things. We just gather them because what we really like is the conversation that is being going on about it. Okay, then let me proceed with the passive equalizer. So the PASEC up here. Generally, the difference between an active equalizer like the PQ and a passive equalizer is that all of the filters that you can see here, all of these low band cut and boost, mid band cut and boost, high band cut and boost, there are 72 different filter settings possible, and in a passive equalizer, this is all just one EQ. And boosting in a passive equalizer means you cut everything else. In the early days, in the 50s, it was no other way possible than doing it like this, because there were no amplifiers around. So you need to passively block frequencies that you didn't want to hear, and that residual sound, you amplify it to get to the level where you need it to. So in a passive equalizer, you have an amplification stage that typically does a 20 dB boost. And in our designs, we obviously use a 120 volt rail amplifier there. And that again helps you to really bring passive equalization to the next level, because in the former designs, the old passive designs, they all were noisy. Because you can imagine you work with extended rails and you work with old parts, and then you amplify everything by 20 dB, then your noise floor is usually like in the -70 range. So that's already audible noise. And with the 120 volt rail, well, there is no noise. So it's just the pure filtering. And so let's dig into it a bit. So over here you have like the low frequency, low mid frequencies. These are switches that select 12 different frequencies on the cut side. And here's the boost side that starts at 10 hertz to 550 hertz. And on the cut side, it starts on 30 hertz and goes to 1.9. If you take a closer look at all of the frequencies that we selected here, now you will find that they are not identical for boost and for cut. They're pretty much all the in-between frequencies that you find. So for example, let's take 180 hertz here, and the representation on the other side is a shit. I just selected the only frequencies that we have twice. Here, great. The 240 over here, for example, do I get out of this one? It's like 270 over here. So, and the next one here will then be 380, and over here it's 400. So at least we No, I probably just found the only exception to the rule. Okay, then the small control up here, that's just the boost, and it goes up to 70 dB. And you can see there are all weird numbers to it because that's a passive. In the passive world, you cannot really tell or predict the amount of turning angle on a resistor is creating the same amount of boost and cut. If you take a look at on an active EQ, you can see that you can do that. It's 1, 2, minus, and 4 and 5, and the same on the other side. You're possible to tweak it in an active design. On a passive design, this is pretty much impossible. Let me see whether I get the lights over here a bit better. Okay, and in the center, the big one, that's an output control, but only here in the passive equalizer we have an output control. With the new PASEC, we changed this to become a plus and minus 10 dB gaining. So you can then add more gain to it or even reduce that gain to adopt this more accurately to your to your stage leveling.
Herman?
Yes.
A question there. Since there are so many overlaps in the bands of PQ, can it be used as a Pultec? And
Yeah,
quote,
yeah.
not sure about the frequency curve though.
Yeah, actually the Pultec was, 2 Pultecs have been the grandfathers of this design. On the standard Pultec, you have like the 2 low bands. Oh shit, here you go. You have like the this section boost and cut on low and the high section boost and cut. So this is the standard Pultec, but only with 4 switching frequencies. We got 12, and you can buy a second Pultec that only does the mid range. So, and we combined the into this. So this is basically the modern interpretation of the 2 Pultec designs that you guys know.
Okay, thanks.
And another difference to what we have here on the older design, this goes up to 20 kilohertz. And in the new design, because people were asking us a lot about getting a higher band going and to even go higher than that, the new one goes up to 40 kilohertz. Now you might think that is, yeah, what is, you can doubt the usage of that, but it seems to have an if you use that in combination with a high boost, you sort of get a lift of the high frequencies that is extremely subtle, but very pleasing to the hearing. It sounds more forgiving and more real than if you would go down to, let's say, 15 or 16 kilohertz and just boost this portion slightly. This always sounds a bit more aggressive than when you go like to a much higher frequency and then use a lot of boost in there. This might have to do with the way that the filter curve itself catches on these frequencies. So that might be the reason for that.
I do have another question. A person would like to really know if you are considering making those devices with a hybrid control setup, like a plugin to help recall. And then we have a following comment that says the hybrid idea would be great for PQ, since I believe the new ones don't have the motorized knobs.
Yeah. I just put this down because and I sit down and come over because that is a bit more to say to this. To recall an analog filter, you need to move the pots. There is absolutely no other way, because you don't have any control voltage that you could apply to make any kind of audio device like a voltage control resistor work in that position. It doesn't work in filters. And the only way you probably have seen in the products that have where they link left and right, the way they do this in analog is that they actually have double the amount of control levels on the left side, for example, and then this other chambers, the additional chambers, control the audio of the right side electronics. That still is not a good thing, because all of your audio has to travel that long distance through the unit to get to this one pot, and you always have channel difference between left and right when you do that. This is a principle that has been used in the 80s, in the 90s, but then went away because it didn't stand up to the quality of that was required in these years, these days. So it is therefore using and motorizing it. We tried that with the old PQ, and yes, we did that with the PQ 2050, and we stopped doing it because, first of all, it was really, really expensive. And the second thing, that people couldn't cope with the fact that what they see may not necessarily be the precision of what they get, due to the hysteresis and the clutch difference that I was talking about before. So it lies in the component itself. Now, the only way that we can think of to get this done in the future is to find or to build our own voltage controlled devices, voltage controlled amplifier, which is called a VCA, or a voltage controlled resistor. If today we cannot combine this with our 120 volt rail, because these parts only work on standard rail, and we cannot use them because that would be the bottleneck. Audio would have to pass through them on one side of the control device. There is a voltage that you have that can be anything from 0 to 5 volts or whatever, and on the other side there is the audio, and that has to be diminished, or the resistance has to be varied. But so you meet it at exactly in that component, and if that side only can deal with plus or minus 15 volt, it doesn't work. And the other thing is, we tried that in standard rail with what you find on the market, and believe me, none of them sound good. They just don't let the dynamics dynamics change. The noise floor rises. There are so many bad artifacts that are introduced by that we said, no, this is, we won't do that. Well, what we currently do is we're working on a 120 volt railed VCA. And that's a hell of a development. But it would allow us to be able in the future to remote control and to store and whatever pretty much all of our devices, if we manage to get this to get this working. We're already like 4 years working on this, and it's always one step forward, 2 steps back, and sometimes the other way around. But it's a continuous process where you realize how it works and it doesn't work. Yeah, sometimes it gets really frustrating in doing so. So that's we keep on developing, and we try to figure a way to get this done. For now, I can only say in analog, no, you need to make a picture and you need to twiddle the knobs. That's it. And believe me, once you start twiddle, there is a beauty in twiddling knobs too. All right.
I have another question regarding the PASEC. With so many overlapping bands on PASEC, how do you deal with phase shifts?
Yeah, the overall phase is not altered by an individual frequency. That might happen within that specific frequency, but if it cancels, it doesn't cancel because it's all additive at that point. It doesn't really cancel it out. But the phase shift is so random and so small and only related to that frequency that you currently work on, that it doesn't affect the overall correlation. So you don't see the change there. No, there is no issue with that.
Yeah, that's exactly what I wanted to ask you about phase correlation between the bands, because there was so much overlapping. And the second question I had was the proportional Q that you were speaking about. I'm very interested to know, how is it that you have designed the gain to the frequency? For example, the curve that you mentioned, it widens, correct? So if I'm going to have a very narrow band at 4K, and it has a gain of say 3 dB, and the moment I put proportional Q, is there a standardized design that you have on broadening the Q and the gain? Is there a set ratio with which you work?
No, a
And
set ratio isn't there, but it's always the smallest Q that keeps that has the amplification or diminishment of your boost cut control. So if you set that to +3, then in the smallest Q it's been +3 in that peak level, and in that center frequency it's +3. And if you broaden it, everything that goes away from that smallest Q will be lowering the overall level. So it does something that looks like this.
yeah,
And then it goes up again and hones in on that frequency. It's extremely musical.
yeah, exactly. That's what I wanted to ask, as to how is the curve moving in. There has to be a variable, right? So it could also be this and could be this and then go flat. So linear, logarithmic, it's just a musical. Is there something that you worked on the proportional Q?
Well, it's as I said, it's a different filter, and that filter that reacts like
A
this.
different filter. Okay.
It's a different filter. It's like you switch from a constant Q to a proportional Q filter, and that filter is it's another filter in that thing.
Okay,
Right?
okay.
So
Because I was wondering, I got it.
Yeah, you literally switch between 2 filters per band. That's why it's such a complex device. It's only one button, and you think, okay, what does it do? It's not much. No, it's exactly, it doubles, pretty much it doubles the filters behind the front panel.
That's wonderful. So I could choose kind of two variable options on a single band. It's almost like having two different options on the single frequency. That's wonderful.
Yes, that's exactly what it is.
Yeah, because I was assuming it's going to be a small change on the same Q that we are working in.
No.
I was asking about the ratio. This is wonderful. That's great.
No, you can imagine when you work with these overlaps and you touch something broadly in proportional Q, but you need to touch something specific in a high Q on a certain, in that range, you have the freedom to do that in the analog domain. And there are I don't know any equalizer on the planet that does that.
Yeah, that's exactly why I was asking you as to why was this? 2 relays is wonderful. That's great.
Yeah. Okay. Anything else on these on the EQs? And otherwise, I would start with talking about the ion.
So far, all good.
Okay, ion. Well, and first of all, a few words ahead, because there is a lot of not confusion, but people may not really know what a variable mu compressor is and how a tube compressor actually works. In a tube, you have an anode and a cathode. So basically the heater, which is the cathode that emits electrons, and the anode, which is a plate that receives the electrons. So that has been used in the first, so we use triode tubes, but the beginning of the tubes were just like diodes. So only 2 poles, anode and cathode. And it has been used, for example, to rectify AC to DC by just not allow to let a negative voltage travel the other direction. It only allows to travel into one direction, and thereby you'll only have the positive halfways, and these are all then a DC. Whereas That's been where tube's been used for in the first place. Now, on a triode, there is something that comes in between the cathode and the anode, which is the grid. And the grid is pretty much a plate where you apply a certain voltage to, and that hinders the full flow of electrons through the grid to the other side, to the anode or the plate where the where the signal is being received. So the grid is actually the most important part in on how to reduce the amount of gain, because that's what a compressor should do. It should produce some kind of curve that looks like this. So there is a knee and there is a portion where you can say, okay, the ratio increases and I flatten my curve, so I make audio sound louder. But compression is not just to make it louder. It has been pretty much become that way over the in the loudness war, and people have used it extensively to apply more and more compression to get a louder recording, and thereby squashing the dynamics, and music becomes like this sausage when you see it on screen, and it's just like awful. And luckily times are changing, and iTunes is looking at it. Even Amazon and Spotify and all of these companies do not allow heavy compressed audio. And if you, since the invention of the E128 papers on loudness units, and that the perception of audio should be ranged in certain loudness units, that was a very, very, very positive step towards reducing the necessity for that loudness war. And today, if you put your super compressed music onto one of these platforms, they are going to diminish the playback level, so that you're actually weaker than the ones who are not that heavily compressed. I think that's all that was necessary, because it totally got out of hand. Now, when we talk about compression, it is not to squash audio. It is to increase the energy of the perceived music. That's the key. And with that, getting it more energetic, it gets this power that you really want to increase in the mix. It's just more convincing, just more self-standing. You know, it has balls, I should say, and that's exactly what the iron gives you. That's a ball creator machine, and it's just been sorry for that.
You're gonna get a reward, an award from KG on this one.
Okay, now in the iron we have two tubes in series, not just one like everybody else does. Our specialty is doing it with two tubes in series, and these tubes are both different ways or different triodes. The one is an ACC 83, which is a remote cutoff tube, and the other one is an ECC 82, which is a how was that called again? A feed forward tube. Yeah, a feed forward tube. Don't ask me exactly what that all means. I don't know. But anyway, the one is been looking at its input, and the other one has been looking at its output in terms of match leveling. So they have two different ways of looking at the gain structure. And we thought that's really interesting. When you combine these two together, you pretty much look at the gain structure from either side, from the input side and from the output side. And we thought that that'll be cool. And it turned out to be cool. Now, the way you manipulate the grid voltage is exactly the way how the audio overall level is being diminished. The diminishment itself is then being compensated by the makeup gain that lifts everything up, so you meet the original input level. And that brings up all of the lower level events lifts that up proportionally, whereas the higher level events pretty much stay at their maximum, only slightly move higher, and thereby the distance, now the dynamic range is being decreased, it's getting smaller, that energizes the music. So you got to be careful not to overdo it, but the sound that you get from a tube that does this almost like inherently in its process is totally different from a VCA compressor or from other types of compressors. So tube compression is very, very generic. And to manipulate the grid, that's what all of the other control functions on that device are for. And I'm going to run you through this right now. So okay, where do we start? We start from the input down here. So there is an input level switch with a boost and cut switch down here. If it's set to 0, this portion has been taken out of the audio path. If you set it to minus, it goes from -2 to +12 to -12. And if you go to boost, it does the opposite way. I usually use this when I master full range material. I use this on the input side, and I cut the input by about 4 dB as you see it here, because I would advise you to do that when you work with full range material. If you set it to 0 like this, full range material might already trigger the processing without, even if the threshold is down here. So we did this intentionally. In the beginning of the design, when we started with that, we didn't want to use this exclusively for mastering. It should also be done for recording, where you are dealing with far less levels on the input side. So that's why the arrangement and the whole setup of that system became like that. And now we say, okay, use -4, -6 on the input side. That helps you to then to work better with full range material. On the output side, obviously, you have the same switch to compensate for any level, for the level differences. And as you can see here, I'm usually do work in the 2 dB range of gain staging. So I'm going in with -4 and I'm going out with +6.
Haman, I have a question here.
Yeah.
So supposing you're mixing now, and you're mixing and you're monitoring through the ion. Now, so you would advise to put it in -1, is it?
On mastering, yeah, negative, yeah. Set the input to -4 or something. Yes, I usually do that.
Sorry, not -1. See, minus, as I can see it in I have a plug-in version of this which I bought last year. So you put it on the negative side. That means basically whether you're mastering or mixing. That is, yeah. If you're mixing it, supposing this is on your master bus.
Yeah.
Okay.
I'm yes, exactly. The input is just how much do I put into the compressor chain, and I don't want to have it triggered already with a full range signal. So I opt to reduce the input slightly, so it gives me more options on the threshold, and I also get to a point where no threshold at all means that there is that audio is unaltered and it's not being modulated already. What could
So the question here was, can you hear me?
Yeah.
Yes. Yeah. So the reason he had asked regarding when he uses a plugin in the mixing stage is only when your input signal is full band, wherein your loudness is quite high, then you do not want the compressor to kind of kick in.
Yes.
So you're going to reduce the gain to ensure that you play around and give a more threshold and allow the processor to work more and then control the output.
Yeah.
But at a mixing stage, when he is doing, suppose his levels are not as loud as it should be, say above below -6 that he would be working, then there would be no necessity to run it down, right?
Yeah, you explained that better than I could. Thank you.
Okay.
Yeah, but on the plugin side now, here, see with the plugin alliance thing, actually you have a headroom knob. Now I'm not sure actually if you have that on the hardware.
No.
But So what I did was actually, when I was working through this plugin, was I kept it at 0 or plus if I wasn't getting the thing, because my levels are usually below -18 or hovering around that. And then I play around with the headroom until I get the right amount. I mean, I rarely actually overcompress anything on my master bus. Not a big fan of that. But when I was checking this plugin along with the shadow hills, I like this one more, at least the layout of it.
The layout of it. Yeah.
Yeah. So yeah, but then I'm going to check with this actually, this negative thing. But of course, on the plugin side, of course, you're specifically talking about the hardware right now. So
Yes.
so I think that kind of, and of course, with size explanation as well. I think I totally agree with that. And I
Yes,
think
sir. So what happens
since
is when it comes to mastering engineers, sometimes the material is very loud, and at that point in time, when they play it back, you might not be able to decrease it at your playback level. At sometimes also it might be very hot for the compressor to take it in. So what happens is you have an option which is very intelligent with SPL. They allow you to tweak it down. You could go down by 248 dB so that the compressor gets the kind of a signal that you expect it to, so that you could tweak with your threshold and then bring the certain color, because tube compressors give wonderful colors, and then at the output stage you balance it out to how loud you want. So for a hardware, it's very very intelligent and wonderful to have input gain staging, especially reduction.
yeah, absolutely, yeah.
Yeah, in plugins you anyway have a lot of other options to reduce your mixed signal to go into your master bus. So you do not have an issue even if that feature is not there. But for the hardware, this is really intelligent. It's wonderful.
Yes.
Okay, then moving on the um, on what now affects the tube grid. And the ones that we're talking about, the gain stages, they don't affect that. That doesn't have to do anything with the grid. That's just gain staging. Now, first of all, what you all know is the attack and the release. So from you can see there is just labeled from slow to fast both ways, and that is because of the fact that we use like a huge amount of rectifiers that you can choose from, and also side chaining, and also tube bias settings. All of them affect the speed of these time constants. So thereby it wouldn't make sense to put any labeling in milliseconds or whatever on it. So because it's all different for a different setting on the rectifier, this would change again. So it's just slow to fast, and you need to use your ears to set them the way you want. Okay, as you can see, I'm using here, it's I set to super fast, and this is not the reason. So I'm using it in a very responsive way. As you can see up here, this needle is really, it does move fast. Sometimes people just like to use it in a much slower movement. Let's say if you, for example, reduce the attack, and then you will get slower movements on it, but also less action. But I prefer it like this for me. Now, on the rectifier side, these are diodes that rectify the incoming AC, and creating and using that to be to rectify the signal to go on the grid, because we need a DC voltage on the grid. And you can see we have like two germanium diodes in here, an LED, silicon, another germanium value, and a combination of germanium and silicium. Um, you probably know that there are companies out there that call their compressors a germanium compressor because they use one of these in there. I mean, we already have 3 or 4 different germanium values in here, and all other rectifiers. Honestly, I don't know a company that does like 6 rectifiers. This is actually like 6 different types of compressors. And when you go use this, and you let's say, you can literally, by the by using the different characteristics of these rectifiers, hone in on an instrument. If you change this and you listen to it closely, you realize, okay, this captures more on the vocal, this captures more on the kick, or and this one does more on the snare. So you can literally go through instruments and find it where you want to have it react in the first place. It's like an instrumental preference selector, if you might call it that way. Then you have a sidechain. And we have like 4 different sidechain EQs already built in. You can have an external sidechain being a filter being put into the input to select the frequency with any kind of other equalizer, and the quality of that equalizer doesn't even matter. It can also come from a workstation, and you just feed it in here, or you just set it to off, and then it's the full range audio. Now, in the EQ 1 to 4, they have the one is just a low pass, and the other one is we have the filter curves in the manuals and on the website. If you take a look at them, you will see they are pretty wacko, and you would think this cannot result in a proper audio, but it actually does. And it's funny when you see how the frequency spectrum are that you use to compress. This is again like featuring certain instruments, or in the case of a low pass, not to react on sub-low frequencies, which the guys in hip hop and these kind of music styles really enjoy. This switch down here is the tube bias switch, and that is actually the overall level or the overall voltage that you put to the grid. It can be low, mid, or high. So you compose your grid voltage out of your time constants, out of the selected rectifier with the selected sidechain EQ, and then you set the overall level of how loud, how intense you want to apply this to the grid. And now the grid will actually hinder the electrons to move from the heater, the cathode, to the anode, the plate, and thereby reducing the audio rather musically. It's been a constant change there, and that is the beauty on a tube, because it's like almost a live type of component or part that does that kind of gain reduction that you want to have from a compressor. Oh yeah, obviously the threshold is part of that grid thing as well. Well, the higher you turn that, you can see that the more action you get out of it. So that's pretty much it. You have this twice, obviously. In here, that's a little filter stage. It's a tape roll-off filter, bypass, and an airbase filter. Now, airbase is a very subtle coil filter put into the about 5 to 6K, as well as the 70 Hertz area. Only just 1.5 dB. I know some mastering engineers who told me I usually do this, and it's what I do anyway with most of the tracks that I receive, and I don't need to apply additional equalizer. Yeah, you can. I say, really? I say, yeah, it's good. So, okay, and I'm talking about very high profile mastering guys. I didn't expect them to use it that way. It was more or less something to tweak a bit of the sound. And the tape roll-off does exactly the opposite. It has the roll-off of a tape machine. So it below 50 Hertz, 60 Hertz, it falls off, and above 15 kilohertz, it falls off. So that's also to combat the sheer amount of too many high frequencies in modern recording, where we record everything up to 20 kilohertz and higher. And at the end of the day, you have so much high frequency energy that, that it's simply a bit too much. And once in a while, doing this helps. The auto bypass is here in as well. We spoke about that. The link. Now this right channel becomes the master when you switch it on, and we managed to get all of these. It's 6 values: threshold, bias, attack and release, as well as the rectifier and the sidechain. All of these informations are being put over to the left side. Only the gain staging. You can't do that with the gain staging. These are all control voltages. and this is real audio. So yeah, that's it for this. And if you have questions, go ahead.
Yeah. Can you speak about the rectifier again, please? Is it tone shaping specifically, or I've still not got the rectifier right?
Okay. Yes, it's tone shaping because a rectifier, due to its core material, if it's been silicium or germanium, all these diodes have an impact on the sound. Right. And even on a germanium, you get different types of values of capacitance in there, and that also shapes the sound. So by having the rectifiers, I mean, shaping the sound is probably not really the word, because what you shape is the grid voltage, so that portion that hinders your audio from going through. So it's basically, you use these diodes to create to let the compressor react on certain frequencies more than on others, and thereby the reaction that you creates a different sound. We have to put it like this, right?
Okay.
So I have another question related to this. So do they decide to what material the compressor is reacting to?
Do they decide to what material
The compressor is reacting to?
Yeah, by their specific electronic, capacitance, resistance, or how this diode actually behaves, how it rectifies the AC into DC, how that process is happening. It affects certain elements of your mix. It's rather abstract to understand, because it's not a direct thing, because audio is not going through those rectifiers. It is just a tool to manipulate that voltage. And if you want to make this compressor react on certain elements, you need, with a tube compressor, you need to be capable of manipulating the grid voltage. Only by this means you can actually affect the sound of the compression and where the compressor emphasizes on. So that's basically what it is. It's like an emphasis selection, if you want to call it like this, for where the compressor should react upon.
Okay, so would it be right to assume that the LED behaves more like an LA to A?
Oh, yeah, because that's I think they used that in there. Yes, it's a typical the LED is also creating the biggest loudness, because it has the fastest attack time in there as well, in their behavior as an LED. The germaniums are usually a little bit softer, and they create a different tone because they are slower in timing, so they let something of the speediness still go through, and you cannot really diminish the audio that much, because the change in voltage, in grid voltage, is coming a little bit later than the event, so it lets through the attack portion, whereas the LED is so fast that it doesn't let the through that it hinders the attack portion to go through, and thereby you lose more overall gain, which you can compensate with more output level and then increase the loudness. So it's, honestly, guys, this is a complex playing field. And when we made the iron, we were like thinking about how complicated are we going to make this device. If you get your head around it, it's not complicated at all. But the complication is more in the sheer fact of understanding what the rectifiers do with your material, with your audio. How do they actually affect the way of compression? Because every time the compressor sounds a little bit different and reacts a little bit different, which might lead you to, okay, if I use the germanium, I might bring the threshold down a bit more to let more information in. That again gives a different sound to it, or you might use a faster attack on germanium and a slower attack on LED. So there are a lot of dependencies that you that you figure out while you play with that. And typically, I must say, I think it's about, maybe like a month worth of experimenting until you fully get your head around this thing.
Don't the LED have the longest attack and release time, or was I confused? Not me, but the person who asked.
Let me just see, the longest release time was on where's that? No, I think the longest release time were on the combination of the germanium and silicon, where we have like, no, the silicon alone, that's 330 nanofarad, and the farad usually coincidence with the speed of it. So there's a germanium with 220 nanofarad and an LED with 3.3 nanofarad. Oh, it's just millifarad on the LED. So even, it's that I think the LED, as far as I know, was always the highest speed because of that very fast attack that it offers.
So in essence, we're getting 5 or 6 different types of compressors in a free rack space.
Pretty much, yes.
Okay, what's the I have many questions. Two of them. One quick. What would be your personal ideal setting for a heavy bass track on it?
Oh shit. That's
Yeah,
that's
that
one
would
of
be great. Actually, you see, because you use the hardware version, so if you could give us pointers as in where it really benefits. I'm sure it'll benefit every area, but particularly on bass guitar, vocals, and the master bus or drum buses. You see,
um
and some settings. That
yes,
would be
yes,
great.
but
Just a
guys,
ballpark figure.
yeah, you are probably better engineers than I am. I'm just the guy who designs this and makes this, but I'm not a heavy user like you guys are. So I do this as a hobby with the stuff that people give me of my own band, and we fiddle around with stuff, and then we rely when we develop, we rely on our what we think it is, and we think, oh, this is cool, or I never used that feature, is new to me, I couldn't find this on any other equipment, so we put it in, and then we pretty much get the feedback from you guys telling, oh, I used it on this track and I used that, and this worked great, but this didn't so much. But when I do this, wow, that was like mind-boggling. And you go like, oh, really? Oh, really? Oh, really? I relearn from you. And
Okay, I'll tell you, I like the silicon. I like the silicon a lot.
yeah, see, that's and I wouldn't argue with that, because as I said, it's going to be so difficult on your what's your goal and what you want to achieve with that within the song. I don't know your song. I cannot tell what your goals are, what you want to do there. I don't know your personal taste of where you want to go. So what I would do is probably different from what you do, and that's good, because if it wasn't like that, who needs more than one mastering engineer on the planet then? Yeah. So we all have our different ways of hearing and liking, and that's the beauty of it. And I don't want to make these kind of a suggestion, because that is not my expertise. I'm just a guy making this stuff. That's it.
Okay, 2 other questions. One question is, could you give us some example for the different sidechain EQs? The frequency response curves are quite different.
Yeah. And that's also down to experimentation. I think we had like EQ3 was specifically to hone in on the or to work on the frequency spectrum where the vocals are usually placed between 300. I don't know. Do I have the I don't have the filter curves at hand right now. but maybe I can find those and we can talk about them. Excuse me, give me a sec. Maybe there is another question in between that I can answer
Yeah.
until I find this.
On the output stage, the XLR outs, are they transformer balanced
No.
or electronically balanced on
Yeah.
all your mastering products?
Yes, we don't use transformers because they cannot cope with the 120 volt rail. They limit the dynamic range that we have in the 120 volt rail, and that's not what we wanted. They usually go up to 28, 29 something dB, but we go up to 33 dB, and we would lose all that dynamic range. And also, again, transformers these days are being used for sound, not so much for operational safety. And that was in the beginning the only role they had to get complex applications like broadcast stations going without all of the hum and noise and whatever issues, to use transformers. These days, all of these transformers now start to produce a specific sound. But I tell you guys, it's not as much as you think. And even in the old Pultex or Universal Audio, it's always the entire product, the whole product, that creates a sound, not just a single transformer that does so much to it. Effectively, a transformer shouldn't be heard at all. But it has a certain thing. It does make the polish the top end, and it gives a bit more oomph to the bass, and it does those things. But on the 120 volt rail, we did not do any of this because of the limiting in headroom.
Okay.
and dynamic range.
I have a more generic question that relates to something that you already said. It's great to watch, learn, and understand the hardware, but for a lot of us who use software emulations of your hardware, how much difference is there between the software and hardware versions? Is the software version just a visual toy / treat in comparison to the real deal?
Well, that would be something, wouldn't it? Well, in fact, the way that that we do this, how the creation of a software emulation of a hardware piece is being done. First of all, you need to select one specific, let's say, iron in the beginning. So we were thinking, which iron are we going to take into that process? As you know, they are all sounding slightly different because all of the tolerances that the components have add up in a device, and you get slight differences. So you have to make a decision on which one you think is the one that you want to be used for the to go into that process. Now, with the plugin alliance guys and Brainworks that actually do these kind of emulations, their specific knowledge is on component modeling. So what they do is they get the schematics from us, the circuitry, and the first step is to build the circuitry exactly as our schematics are shown in the digital world. So it's a one by one thing, and then it's the same circuitry as such. But obviously, you can understand a tube is sort of an amplifying device, and in a digital representation, it is hard to you create one version of it at one specific level, maybe at 2 or 3 different level points, but the continuous flow of changing levels through all of the components is so much of information and so difficult to compute that you have to select certain points. Okay, we're going to run this at 0 dB, and then we go up in 1 dB steps. And everything in between isn't there because there's no representation in the software for these settings. And there is a limit to how precise you can actually go through the dynamics of it, you can do all the schematics. You can represent all of the different components, and Plugin Alliance has a specialty which I find rather cool. They have a component a modeling technology where they can change the tolerance. So the tolerance modeling is part of their modeling process. If I'm going to tell them this is a 20% tolerance component, or a 5 or a 2 or a 1% tolerance component, they can put that tolerance in their system, and they can let this tolerance be change slightly over time or for various settings. But the logic behind how it does that is something that is, again, a routine, an algorithm. Whereas in reality, a routine doesn't really exist for that. So you need to come up with something that emulates that somehow. Closer and closer, and specific device that you have on your desk, not to all of the other devices that run out of the factory, because they might be different, because all the tolerances in their parts are different. They come from different charges, they come from different lines, they come from different continents, sometimes from different fabs, whatever. And so they all have their individual character. In analog, I truly like that. And that's also the reason why sometimes you find people say, "Oh, I bought this equipment, and it was from this year, and it was sounding totally different than the same unit from that other year or from that other period." Yes, because that's where you get your parts from, and that all has an influence on it. So the final stage, in once this is all been programmed, we meet at Dirk's place in which is like an hour away from us, and we're gonna sit in his studio, and we usually just play music, single instruments, full mixes, full masters, and we have the original hardware that they have been modeled, and we have the software emulation, and then we go through settings. We try to say, okay, this is what I would do in the analog world, how does that represent it in the digital world? And you try to mimic the settings, and then you compare the audio between them and see how close have you gotten. But you need to understand there is always an ADDA conversion and a different, and the level, the gain staging is also extremely important. The wires or the cables, everything becomes an issue suddenly when you start to compare. Now, I cannot say that the digital version is 100% of the analog. That is impossible. It is just from the way it is. Everybody who says that is just ignoring some true facts behind the process of creating these algorithms. You spend a lot of time, we spend then with them a lot of time in retweaking. And I like see if that is going to the maximum, it doesn't do that little and it doesn't do that. Why doesn't it do that? It does it on the hardware. I need to figure that out. And then they start, they found ways of when there was that they can tweak the algorithm while we're listening. That was a huge step, and I know, and it was some really extraordinary things that Plugin Alliance or Brainworks came up with. That they said, okay, I think that capacitor there, if we change that value from 100 to 110 nanofarad, it would actually start to behave differently. Let's see if that gets closer to the original. So we do that, and we work on it, and it's like hours, it's sometimes days, where you sit there and you meet the next day and you go through it again. It's a long process, but at the end of the day, you get the mimic of one specific ion. That's it.
It's more like a snapshot. That's the thing that's my take on this plugin thing.
Yeah, it's a snapshot of that thing, of that setting, of that. It's exactly that. Yeah, and it's always only that one single piece, and it never changes. So you don't find a software that sounds different than the other software. That's impossible. Like you would have on hardware, it's just a different thing. Oh, I prefer this. See, that's the same thing with microphones. See, there's you get microphones from the same manufacturer, and you take the one and the other, and they do sound different. And you think like, oh, that's not good. Yes, it is good. Believe me, that's a good thing that they are not sounding all the same. Because when you really work with them, you understand. I use this one for that, and I use this one for that, and it's brilliant. If I would swap them, it wouldn't be the same result, and I wouldn't like it that much. So embracing and starting to work with all these differences, and that comes with age, that comes with time that you spend and doing these things, that you learn to love these differences more and more and more, and you get to the point, okay, there is endless exploration ahead of me. I don't think I will ever find the end of my way. It's the way is being on the way is what it is. And if you find peace with that, you start to look at things quite differently, and you start to take a look at, okay, the best usage for that part is with this and with this, and you know it, and you work like that. And that's sometimes where you then figure out, if I do this, I don't need to do more to that. I don't need to apply an EQ anymore. When I use that microphone with that instrument, I'm fine. It's always capturing the real thing. And I'm sure Mr. Singh has something to say to that with his experience as well. So I hand it over to you for a minute.
KJ?
Yeah. Yeah.
Would you? Oh, yeah, KJ.
Yeah.
What? I mean, is my take correct or not?
No, absolutely right. Herman, what you've said is a very valid point, and how you've explained your products over a series that you've done with us has really taken all of us through the steps of what your products do, and the thought and the entire vision behind it. And I totally see that, especially in the dealing with the hardware and the software. Uh, I think my generation gets asked that question a lot more than the newer ones, because we are the dinosaurs who dealt with analog hardware, and then now we are shifting over to software as well. So I run a hybrid system, like I'm sure does Sai and a lot of other engineers. So we are constantly battling with this. I have the same hardware and I also have it in software, whether it's from BX or whether from UAD, and sometimes the same plugin in like 4 different companies who are dealing with that plugin, and each one is different. I think somebody else also mentioned here that it's like a snapshot of that entire range of what that hardware can do, that we are encapsulating in that one snapshot for that plugin to kind of take care of that. So obviously it will not be the 100% of that hardware. So
yes.
And I in my personal experience, it was in the headroom. So just to give a very quick example, if I'm running everything with where the gain structure is beautiful and everything is organized very well, and you don't have too many loud tracks, and you're just doing some light music, and if you feed that into a software, you can drive it to a point and then it'll be fine. But the moment you are looking for color, drive things beyond a point, you can't drive that plugin. But on the hardware front, you can drive it some more and get that extra juice and extra color out of it, which is not possible in the plugin. It's been my personal experience. I don't know how many other people have felt that, but that's where the divide and that's where the difference comes in for me more than anything else. The headroom part of it, really.
And if I have to add to the tubes, every time I power up my tube compressor or a tube microphone, how it sounds is so different 4 hours later. And the next time I switch it on the next day, it's going to be totally different. That's one thing that people have completely forgotten. And every hardware that you have, even from SPL, every tube that comes is going to have a color. So if I'm going to own an iron, and if KJ is going to own an iron, we are going to have 2 slight different characteristics of the tube by themselves. And it's also how much you run it, how old they are, what happens to it, how much you saturate it. Even with microphones, as Mr. Gia was telling, when I start recording a song and 1.5, 2 hours later, the tube just saturates, heats up to a certain level, and then the take that we start at 9 a.m. to 11 a.m. takes are so different in color. And if you have the ear for it, if you have the sensitivity for it, you will realize that hardwares they are mystical. That's the right word. They are very mystical. You keep learning. you keep hearing new things from it. In fact, there are times that it teaches you way more than what plugin does, because please understand one thing: despite a hardware, when you touch, feel, and when you actually work on it, there is a certain energy that you start to sonically feel, which in a plugin you have a lot of visual influence that you end up having. Okay, this is the setting that I used previously. With the hardware, you start to, when you start tweaking, the kind of sounds that you end up hearing is so different. It is so different. I cannot tell you how much, when you drive a hardware, especially EQs and compressors. When I just saw this question here saying, I knew that it would be unfair for us to say that, emulations are no match to hardware, because today the whole world lives on emulations. But I must not hesitate to say, I think there is no match to a hardware. I should not be hesitating to say that.
It's actually really true what you just said about the curves and EQ. What you would do when you would just fiddle with the knobs without having a visual representation of what you did. We have a sense of if something looks weird, we think it would sound weird. So we try to make it look smoother just to please our ear, and then think, no, now it sounds better than before. So that gets me to the point where this we had this question on the curves, and let me just share my screen over here, because I found that that part in our manual. So can everybody see that?
Yes.
So this is our EQ curves on the presets. The preset 1. Oh, by the way, this has been changed, and we have to update it. I think this is still the old manual on the website. The preset 1 now is a low pass, so it has a different curve like that. Preset 3 goes like this, and this one is the weird one, preset 2, like this. But don't mistake this for a curve where you say, okay, now my vocal, for example, is being diminished by minus 12 dB on 500 hertz. No. It has nothing to do with audio. This is just the frequency range where your compressor reacts or does not react so much. So if you tell him, leave that area out and don't react in that area, it will actually do not compress that part, which means as a result, your vocal, which is pretty much in that area, will be climbing out of the mix a little bit, whereas the rest goes down. So you have a means to readjust the level or the presence of that vocal with that kind of a preset on a compressor. So
it's like a subtle multi-band.
it's almost like a subtle multiband, what you can do, yes. And the weirder it becomes, like this is a super weird curve, the preset, the former preset 1, with this little hard dip on the 2K area, which is the area where most of the where our hearing has the highest sensibility. So this range is naturally our best between 1 and 3 kilohertz in that area, or 1.5 and 3, the area that we hear the most. And if your compressor does not react on that, it leaves that pretty much untouched. And then you get a sort of, if you want to increase intelligibility, this is the preset to do that, right? So, but again, what you see here and what you create with your filter when you make these kind of curves where your compressor should act upon, it has nothing to do with that you actually would emphasize or cut any frequencies. No, you would actually do the opposite of that will happen in the dynamic dynamic domain. All right, so let me stop that here and we go back to our other side. So right, okay, anything more, Xavier?
I have a question here about the EQ.
Yes.
Why did you choose not to have a low cut in case I have to work just with there are subsonic things that I might want to not have when I EQ, and been a great addition on the PQ.
Yeah,
Any
it
reason
has.
specifically? Because when
It
you do not want to add any other EQs and just work on PQ for the color.
okay.
It would have,
There were certain. We've been discussing this at length, and the same applies to the high shelf, high bell, whatever
Yeah.
filter as well. First of all, when you use the widest Q on the high setting, the widest Q, you pretty much have a shelf. So it is there, but it would actually take away the sub bass band on the top level band. So that would be a loss of two bands, which you might want to use for others. Now you might argue, yeah, but you have such a big overlap so that you can still do the bass end with a low mid frequency. And if you have so many problems in your mastering, then you should rethink the mix or whatever. But when we designed this, and this was like over 20 years ago, we really wanted to emphasize on the possibilities of what a 5-band fully parametric EQ could give you. And we couldn't have done this if we would add the shelves. Then it would be a top shelf, a low shelf, and a 3-band parametric. That's pretty much what everybody else did. So Focusrite did it that way, and Avalon did it that way. And we thought, yeah, but okay, they only have 3 parametric bands. So we add 2 more parametric bands, and we can do the shelf or use it as another full parametric with the proportional Q that nobody else had. So I couldn't really get the argument, because we had 5 bands. That was what everybody else had too, 5 bands. But we had the highest flexibility on these 5 bands. No, so that's why I couldn't follow the argument really, and I thought, hey, why are they still asking for that? Do they really want to have a low band and a high band and 5 parametric in between? Okay, so right now we have another product in development for mastering, and it's a stereo, a bus equalizer on 120 volt rail. And yes, in this one we feature this at length, with capable you can switch bell and shelf characteristic and everything. So yeah, it's there. And over the years we understood that this is going to be necessary, although we thought it wouldn't, because you could do the cutting very precisely and neatly in the digital domain. So I was really not getting the point either. Why wouldn't you do that? If you don't want to have frequencies below 20 hertz, you can cut that in the digital domain better than in the analog domain, because the steepness of the filter, although I'm not a fan of super high steepness, that always has, to me, it doesn't really sound natural. I like smooth filters, but when you really need to get rid of something on the cornerstones of your recording, why not start doing that digitally, and then with this output you go into the analog compression, into the analog equalizers, and do your sound thing there.
Yeah, that was specifically because when we do archival work where we have like 200, 300 materials that come to us and you have to master them, sometimes just having a knob there could help us, not send all these 200, 300 digitally cut. That's why that it's a very, very important part for mastering archival work. That's all. That was my concern, because I do a lot of archival mastering.
Okay.
At that point, what happens, this really helps, that, up to here I cut and then let's go, and just makes the work very fast rather than handling 200 different files. That's all.
Oh, that, yeah. Well, cool. Thank you for that. And okay, we will have a toy then soon.
Great, thank you.
Yeah. Okay. Anything else?
No, I'm good so far. Oh yes. Is oversampling built into SPL plugin emulations?
Yes. Yes, up to 8 times. But it depends on the process itself. There are some processes. I'm not a digital expert, but they told me, well, you can adapt it here. You shouldn't adapt it there. There are things that seem to be, yeah, weird when you do that. But in general, if precision is needed, and if higher precision is needed, they do oversampling. But that requires processing time. That requires then makes the latency of the plugin itself bigger. And so it's a trade-off also that happens there. Yeah, but in a complete mastering or mixing situation, you don't care too much about latencies because everything is time compensated anyway. In a live recordings environment, that's a little bit different.
I'm good.
Great. Thank you very much.
Okay, so yeah.
I had an award again for Herman this time, and the award is preceded by a very quick small story. Roger Nichols, the guy who was seven-time Grammy Award-winning mix engineer for mostly Steely Dan's work.
Yes.
In the early days of when the Apple came out, they had a voice recognition system which could trigger commands with your voice, and this was really early 80s or mid 80s. And he every time made a mistake, said, "Oh shit." So he actually recorded his voice saying, "Oh shit," and every time he said that, the computer would undo one step back. so the award for that kind of thing goes to Herman today for saying it at least about 4 times when he made that something or the other. So Herman, that's for you today.
Oh shit.
Oh shit.
Herman, I still have a question that I missed so far. Someone wants to know about the THD this particular unit induces.
Well, the iron is the question.
Probably.
Let me just go. Well, just I look it up before I do anything. THD.
Yes.
Yes, THD at plus 10 dBu. So you put plus 10 dBu into the device is 0.002% on tubes. That's good at that level. Yeah.
When I stopped reading THDs because I just follow my ear beyond a point.
Honestly, yes.
When you start reading these are just for the electronics, but you have to trust your ears. And
I'm 100% with you.
Yes.
But still, I mean, for you as when you work with this is exactly what you should do.
Yes.
And there is equipment, when you look at the specs, you just go, oh no. And then you put it on, you can like, oh yeah. So it gives you exactly the opposite and you love it for that. So don't be fooled. When we as designers work on it and our goal is to be, let's say, to maintain this kind of noiselessness in order to give that quality, pass that quality as along to you guys to work with, then we need to take a look at all of the specs and figure out the best way of improving that. But it doesn't really has anything to do with how something sounds. And bear in mind, measuring all your equipment, what can we measure? Frequency, amplitude, phase response, THD. That's it. Doesn't I said this before. I've seen flat lines, linear response curves from I don't know how many processors, and all the time you put them on flat, they do something to the sound. They all sound somehow. Even if you set everything to flat, there is something, but it's a flat line when you measure it. So a flat line is not a flat line. Full stop. If you bear that in mind, everything has a characteristic. In digital, that might be different, I have to say. But in analog, there is this thing. These are almost, I wouldn't call it a live components, but yes, the way that they change their behavior over time that you work with them, over the age, over the amount of heating up, the hours and whatever. All of these things let this appear to be alive things. And that becomes, in the beginning, you think it's annoying because you cannot replicate. But the more you start to work, at least that's what I mean. I'm not you, but I get this from some guys that I talk to, and they speak about their experience, and they're gonna talk about recall, and they say like, hey, if somebody tells me that hi-hat is too loud, and I have to reduce the hi-hat level, fuck it, I'll mix it again. Because if I would reduce that level, it wouldn't be what I wanted in the first place anyway. So everything has a dependency on something else. If you change that, it changes something else that you need to compensate for. So you start again. And bear in mind, the recalls that you could do on an SSL back in the 80s, where you had these tracks and you could fiddle with the pot, and then a green light LED would illuminate once you get close to where the recall voltage is. Every pot on every chamber has 20% of tolerance times 1,000 pots. Yeah, you could scream at your assistant, well, it's not the same. And he could say, but I set it all so that the green light was on.
Exactly.
Right. So what is the value of it, of the recall? Yeah. Things that come over time, obviously, or that change the way you work, and you realize if it's, yeah, and recall is not, the value is overemphasized on recall, I would say.
I must just add something to what you said. What you heard today is not the same when you hear tomorrow morning with your ears. So with that in mind, we must handle audio.
That's actually also true.
Yes.
This I mean, when you get your head around it, that everything is constantly in a flux and never the
Yes.
same.
Yeah.
You appreciate to start the moment, to that moment of recording, that moment of, you start to appreciate that more and more and more, because that is what it is. And if it's great at that point, it will not be the same or better or worse tomorrow. It's
Exactly.
capturing that moment.
Absolutely. Fantastic.
So
I have
yeah.
another one. An off-topic question. Is there some level of imprecision in adding up of samples when a mix is summed digitally?
Is there some level of imprecision in adding up
of samples
when a mix is summed digitally? Well, I don't know if I understand the question 100% by adding
What
up.
he means is, if there is a multi-track, and if you're going to sum it in analog domain, like send it through your mix stream, is it going to sound very different than, or is there going to be distortions when you're going to sum it up in the box? How does it differ? Yeah.
We had the analog summing last session, but I want to recap on this a bit. And I let me start with the digital summing, and because I had the Cubase, and they told me that there is a lot of different approaches to add samples or to add tracks. If you have 48 tracks and you sum them into two, specifically when you are working on in single sample rates. And okay, excuse me if that's if I repeat myself from the last session, but maybe that wasn't clear enough. So the decision that needs to be made is whether you are going to put a sample that comes in. They all have their individual phase responses. They all their micro timing. Let's use micro timing, because phase response, it may sometimes, phase is a bad word, and it isn't. As a matter of fact, just out of phase stuff isn't that cool. But everything else is just a movement in time. So if you have like two samples and a frame here and a frame here, but you have in between these, you have like 20 different tracks that are actually in time somewhere in between. Where do you place them? Into this sample or into that sample? That's a decision that has to be made from the algorithm or from the designer of the algorithm, how to treat these things. The higher the sample rate, the closer these frames get. And the less problematic it's going to be, because then you have like more decisions. The decision is not that big. But in single sample rate, you can see that you time align the events. And by doing that, there is a positive and there is a negative effect, I might call. The positive effect is, oh, you get a lot of punching in your face. The negative effect is you don't get a lot of depth. So these are the two things that actually happen. And in digital, another thing, level. Adding up levels in digital means that you soon get into this, because you don't have any headroom in digital. You need to be very precise, diminish all the other tracks so that your master level is not getting out of RAM, or you use the master fader to compensate for the increase in level. So that's that all affects the gain staging within the system. But that also applies to analog gear, the gain staging. That's the same thing. And that's why we opted to do high rail bus summing instead of standard rail, again, because you can our competition is diminishing the inputs with fixed resistors by like 6 dB for all tracks to prevent the output from clipping. And we don't have to do that. So we can live with full throttle there.
Okay, we've been through all the other questions.
And we've been in time, right? It's 12 o'clock. Yeah.
Well, considering that the session should have been 1 hour, yes, we're on time.
Oh.
But with the jet lag, with the time difference, it's fine.
I thought it was
okay.
2 hours, wasn't it? Was it
we
1
didn't
hour?
say anything about it. Don't worry. It's fine.
I'm sorry, guys.
No, a lot to say about it. So no, don't worry.
Well, in that case, thank you, Herman. Thank you, Xavier. Thank you for the session. And a very special thanks to Sai sir. Thank you very much for the session.
Thank you.
And that was mastering part 1 for you guys. And I request everyone to be part of the next session. Same time, 2:30 to 4:30.
More or less.
On Friday, hosted by KJ sir, who is also here. Very special thank you to all of you. If you have any doubts or queries, do shoot me a mail. My email address is vivian@promusicals.com. We have some of SPL's products in stock right now with us. So if you'd like to try or want to buy, give me a call or just write to me. I will be happy to talk and clarify your questions and help you guys out. So on that note, thank you, everybody. Have a great day.
Thank you.
You too.
Bye-bye.
Thanks a lot.
Very much.
Cheers.
Thank you, Sai. Thank
Bye.
you. Bye-bye.
See you. Bye-bye.